Hello everyone, this is Jean from Linkurious here. I'm joined today by Elise. Today we are going to be talking about graph visualization and Oracle Big Data Spatial and Graph. So let's get started. So for today's webinar, we will discuss how to visualize Oracle Big Data Spatial and Graph with the Ogma Graph Visualization Library. First, let's discuss the agenda and the speakers. My name is Jean Villedieu. I'm one of the co-founders of Linkurious. And today I'm joined by Elise, who is a marketing project manager at Linkurious. She works with Linkurious partners and clients to cover the emerging graph technology use cases. In today's webinar, we will be discussing first what is Linkurious, then we will do a brief introduction to graph databases, and address what are the specific benefits of using Oracle Big Data Spatial and Graph. We will then explain what is the impact of graph visualization for Oracle Big Data Spatial and Graph customers. And after that, we have prepared for you a demo that will demonstrate how to integrate Oracle Big Data Spatial and Graph with Linkurious Ogma Graph Visualization Library. And finally, we will discuss the technical details of that demo. But now, I will start by introducing Linkurious. So Linkurious is a graph visualization startup based in Paris. We have a couple hundred customers around the world, most of them in the US, where we work, for example, with NASA. Our product is used in a wide range of use cases, including anti-money laundering, intelligence analysis, cybersecurity, or medical research. For today's webinar, we will be focusing on Ogma.js, graph visualization library that is used by your customers to build interactive custom graph interfaces.
So, to begin with, Linkurious solutions like Ogma rest upon graph method and technology. So I will briefly tell a word about graph databases before jumping to Oracle Big Data Spatial and Graph and Ogma integration. So, as you might know, graph databases are a type of NoSQL databases that uses graph theory to store map and query relationships. And those systems have been skyrocketing in popularity in the last years. Since 2013, the DB Engine ranking platform registered a popularity increase of 500% for graph databases. They still represent a small equipment percentage compared to relational databases, but their market shares keep increasing. And those systems have the particularity to store data as a graph of entities called nodes and relationship called edges. And this actually explains a lot about their success. Indeed, in today's complex and vast datasets, graphs are everywhere. The data is highly connected, and the value of it often lies in the relationships rather than the data itself. So, graph databases allow to query through connected data to answer business questions. And the analysis of graph data is a decisive asset in many fields, such as cybersecurity, intelligence analysis, or financial crimes investigations. And the graph approach is the best way to understand how data is connected and to take advantage of this. So you can find insights in large graphs and discover non-obvious relationships between entities. As of today, many companies adopted graph technologies, from fraud detection units to IT management departments, and the trend is growing very fast. So, almost 2 years ago, Oracle decided to step in. And in May 2015, they launched Oracle Big Data Spatial and Graph to enable spatial and graph use cases on every big data platform. Their solution offers a set of analytical services and data model that support big data workloads on Apache, Hadoop, and NoSQL databases technologies. So Oracle Big Data Spatial and Graph was designed to uncover relationships and patterns in big data so that companies can better understand their customers, their performance, or even their risk. But the thing is, graph database is not enough. We see the best organization combining it with visualization to help humans make smarter decisions. Because visualization is used when analysts needs to review alerts or run advanced queries, and it actually leads to a faster and more effective result. And we will see that later on in the demo. But yeah, so the thing is, when we look at today's ecosystem, we see that it can still be a challenge. For instance, systems like Oracle Property Graph offer a very high level analytic services to their customer, but the solution does not include graph visualization tools to easily investigate the data. So there are existing data visualization toolkits and platforms to set up interactive charts and visualization. However, they are not designed for the analysis of graph data and not directly compatible with Oracle Big Data Spatial and Graph solution. So finally, among the visualization libraries dedicated to graph databases, there are a few are able to tackle the challenge of big data. The existing solutions are indeed unable to properly interact with more than 10,000 nodes and edges. And the large amount of data to process require high performance capacities. And this is actually to answer those needs that we developed Ogma, which is a JavaScript visualization library for large scale graph. So yeah, Ogma is our client-side JavaScript visualization library that is compatible with more than 80 browsers and any devices so that companies can integrate a reliable and scalable graph visualization component into their applications. It is built on a powerful rendering engine that supports WebGL to display graph of 100,000 of nodes and edges. And its plugin-like architecture gives developer the ability to customize their interface based on their needs. For instance, they could change the style, add icons, change the color, change the font, or they could decide to customize the interaction with different layouts, with geofilters, for instance. So yeah, today Ogma integrates seamlessly with Oracle Big Data Spatial and Graph. And by combining the capacities of graph databases and analytic services with graph visualization, businesses can tackle various challenges in an efficient way. So before jumping to the demo, we will review three different use cases in which Linkurious solution has proved to be an essential asset. And the first one will be the fraud detection in the Panama paper case. So in 2016, our graph visualization solution was used by the international consortium of data journalists working on the Panama Papers leak. They had more than 2.6 terabytes of highly connected data, and the processing was made possible by graph technologies. Because graph analytics helped to focus the investigation on individual connection and visualize highly complex networks to understand the ties between people, companies, and trust incorporated in tax havens. In the end, it was more than 350 journalists that collaboratively identified tax evaders, criminal money launderers, and corrupt public officials. In another field, NASA also uses Linkurious and graph visualization, but this time for graph-based search. They had a very large amount of previously learned lesson, and to be able to take advantage of it, they built a topic model for a subset of 2,000 of them to easily access and navigate the available knowledge. So the graph technology allowed them to connect disparate documents from their knowledge database and to search through it to leverage their data. Graph technologies are perfect to first store complex structure and unstructured information, and also to visually search and discover connected topic to capitalize on existing knowledge and data. So finally, our last example of what can be achieved with graph technologies concerns IT management. Um, Companies' IT infrastructure are growing in complexity. And for IT departments, the impact of, for example, a failure in IT network can be hard to estimate and to communicate. Or it could be upgrading an aging network that becomes a struggle without a proper understanding of the infrastructure. And that is where graph technologies can step in to help store and map the connections between each entity in the architecture. So with graph visualization, it becomes possible to answer day-to-day questions or to communicate complex results and in the end to drive the appropriate actions. So now that we have seen some use cases, let's try this with Oracle and Ogma in a fictional fraud insurance investigation case.
Thanks, Elise. So we have prepared a bit of a demo for you. It's based on the Ogma graph visualization library and also on Oracle Big Data Spatial Graph. We have built an application using these two technologies, and we will be showcasing that right now. So for the purpose of this application, we will focus on a fraud-related use case where we will try to investigate some insurance data to uncover a ring of fraudsters using Oracle Big Data Spatial Graph and Ogma. So let's get started. Okay, so here is the interface of the application that we have built and which integrates the Ogma graph visualization library. We are going to get some data out of Oracle Big Data Spatial Graph. Okay, so what happens here is that we get some data out of Oracle Big Data Spatial Graph, and we are now visualizing it. So we can see some things already, and I can zoom in and see more information about the data. So for example, here I can see that we are looking at a node which has a name property called Dale Schamberger. It has a category property which is customer, and so on and so on. So it's a bit hard at this point to understand what is really going on. So let's try to make this data more easily to understand. To do that, we will use some graph visualization techniques. So the first one is that we are going to style the graph based on the properties that we have. So I'm clicking on style here, and we are going to associate a color to a particular property of interest. So let's focus on the category property. Okay, I'm clicking render, and now we can see something different. So on the top, on the bottom left corner here, we have the breakdown in terms of categories, and we can see that in green, blue, I guess, we have the evaluators, then we have the email addresses, then the social security numbers, the claims, the phone numbers, the customers, and the addresses. So we can get a better feel for what it is that we are looking at. Mostly it's data related to customers. Okay, I can zoom out a little bit once again, or I can zoom in. If I want, I can use some other properties to display data. Perhaps I want to associate an icon with the categories, and I'm going to do that. Associate an icon with I don't know, with the evaluators and with the addresses and categories. Okay. And we can see that now we have some nice icons. Okay. And I'm going to keep on customizing my graph visualization. If I want this time, perhaps I can map a particular numerical property to the size of my nodes. Let's go with the amount property. I'm going to choose what will be the minimum size and the maximum size based on that amount property. Okay, I apply that new filter, and I can see that some of the nodes, and specifically the claim nodes, are now sized based on these properties. Okay, these are a claim, for example, and we can see a very tiny node. So it's perhaps not super relevant, as all the nodes seem to have the same. All the claim nodes seem to have the same style. So I'm going to to delete that operation, and we are just going to style based on the color. Okay. So we have applied a particular style. Now let's try to perhaps apply particular layout for data. And we can switch from this. We can switch from this current fuzzy layout to perhaps something more hierarchical, like that. Once again, we are going to render our data, and we can see that there's something weird going on. I mean, we can see a lot of the same things here, but here we can see something weird going on. Okay. So there seems to be a sort of unusual pattern where we have one customer, another one, and another one, whereas in the other cases, it's always one single customer on top and then a bunch of information related to him. So it's definitely something of interest, and we are going to try to explore that and to investigate further. Okay. So I'm going to now to show how to filter the data, and we are going to use the Ogma graph visualization library to filter the data, and we are going to filter based on a particular property. This time a follow-up property. So that's typically something that could be computed by your own risk engine or fraud engine, and then added as a property in the visualization. So I'm going to use that property to filter out the data, and lo and behold, we only have one small graph left, the one that we had identified visually. Okay. Perhaps I may want to go back to the 430 layout. So I'm going to do that. Okay. Or perhaps I want to try a new, more concentric layout. We have in this regard a few options for you to choose from. Okay. Zooming a little bit now. So we are going to inspect further. So what do we have? We have a person here called Werner Schiemann, and that's a customer in orange. We can see that Werner has a phone number here. He has an address, and he has here a social security number. Here we can see that he shares an email with another person called Paula Smith. Okay, that Paula Smith also has a social number of her own, but more interestingly, she shares a phone number here with a certain John Piggyback. And what's interesting is that John here and Werner here have a lot of common connections. So a lot of indirect connections. They are not directly tied, but they are tied to this node here, a Killy Beans with a lawyer as it appears, and a Patrick Collison with an evaluator as it appears. And it seems like these two individuals are also linked to 1, 2, and 3 claims. So basically, John and Werner are associated with people associated with the claims that they were involved in. And at the same time, they are sharing some common links with a Paula Smith. So that's the sort of insights that can be derived from graph visualization. First, by getting an overview of the data, we were able, to identify an outlier, and then by looking closer at that outlier, we were able to understand what is going on and to pinpoint some potential fraudsters. So these sort of techniques are used by our customers in the field of financial crime investigation. So that's a brief demo of Ogma through the Ogma Showcase application that we have built. Of course, it is possible to build over different graph UIs using the Ogma graph visualization library. And now I will, let Elise explain a little bit more the technical details behind the integration of the Ogma library with Oracle Big Data Spatial Graph.
Thank you, Jean. So we are going to come back to our presentation. So as we have seen, graph visualization is an efficient solution to quickly investigate large data sets and discover hidden insights. So on a more technical note, here are a few details about the integration of Ogma in Oracle environment. So in order to connect Ogma to the Oracle server host, we developed a specific connector that translates the data stored in Oracle Big Data Spatial and Graph into a list of edges and nodes for Ogma to display. So this connector is registered to compliant and handles the connection and queries to the Blueprints API. It is then possible to embed graph visualization tailored for your users into a web application. So to conclude, we've seen that with Ogma, you can build interactive and custom graph user interface that empowers people. This large-scale graph visualization solution is now compatible with Oracle Big Data and Graph environment, and you can choose to visually investigate threats, to review alerts, and in the end, to make smarter decisions.
Thank you, Elise. So thank you everyone for tuning in for today's webinar. You can also reach out to contact at linkurious.js to set up an evaluation of Ogma and start using Ogma.